Assalamu alaikum wa rahmatullahi wa barakatuh. Dear grade 11 students, in this video I'm going to let you know how to read a graph. Okay, so as you see, this curve consists of two parts. Then definitely it's a curve of a discontinuous function. Okay, notice that this is the function whose curve is this one. Notice that for the denominator it's x minus 1, then this function is not defined at x equals 1, and there is also discontinuity at 1 as well. Now, to first of all write the domain of definition, to determine the domain of definition for this function, it's clear that it is r minus or except the value that's equal to 1, and if you want to write it in the interval form, it is from minus infinity till 1 union from 1 till plus infinity. So that's for the domain of definition. Now let's talk about the horizontal asymptotes. If you can notice here, there are two blue lines that are parallel to the x-axis. Then definitely these lines are in the form of y equals k, a constant. Now these represent the horizontal asymptotes. What's the meaning or what's the idea of the horizontal asymptote? Let's get started. Now as x goes towards plus infinity, so as we move that way to the right towards plus infinity along the x-axis, notice that the curve is just limited by the line that's equal to, whose equation is y equals 1. So let's continue. As we go towards plus infinity, as we keep going on, the curve is staying parallel to that line. It's never intersecting it. Okay, so at plus infinity, the curve remains parallel to that line and it's never intersecting it, and that's the meaning of the horizontal asymptote. Now, analytically, the meaning of the horizontal asymptote is actually the limit as x tends to plus infinity of that function. So the limit as x tends to plus infinity of f of x, we can deduce that the limit as x tends to plus infinity of the function that's named, for example, f of x, is exactly equals to 1 using the curve here. Okay? Now let's talk about its limit at the minus infinity. So at the minus infinity, so as x goes to minus infinity, as x goes that way, okay, as we keep going to minus infinity, notice again, the curve is approximately parallel to the line whose equation is y equals minus 1. So there is another horizontal asymptote, which is y equals minus 1. Again, it never intersects the line or the asymptote at minus infinity as we approach, as we go to minus infinity, while it may intersect it at a certain point, but at minus infinity, the curve will never intersect the asymptote. That means that the limit as x tends to minus infinity of f of x is equal to minus 1. So the two horizontal asymptotes for this function are, or for this curve are, y equals minus 1 and at a plus infinity. So this is at minus infinity, and at a plus infinity, the horizontal asymptote is y equals 1. Now that's about the horizontal asymptote. Now let's talk about the vertical asymptote. That's the green one as you see here. That's the vertical asymptote. Notice the curve is going parallel to it but never intersecting it at 1. It's not defined at 1 as well. The function is not defined at 1 as well. Now let's talk about the limit at 1 minus and at 1 plus. So as x goes to 1 from the right, that means we are studying the limit as x goes to 1 plus. So when we say x tends to 1 plus, means x is approaching 1 from the right, and here is the point, so I'm moving the point in that region, so as if I'm approaching 1, not for the values here, it's 1.2, it's 1 here exactly, 1.05, 1.2, 1.1, 1.05, it's nearly equal to 1, it's just a little bit greater than 1. So that's what we mean by x tends to 1 plus. Now, what happens to the function, to the curve? The curve is going upwards towards plus infinity, and thus we can write that limit as x tends to 1 plus of f of x is equal to plus infinity. So let's talk about its limit as x tends to 1 minus. So as we approach 1 from the left, we are talking about the value 1 minus. So as x tends to 1 minus means as x approaches 1, but from the left part, from here. So let's use the slider again. I will delete these. So here is for the slider, notice that it's not 1, it's here is 1. So 1 minus means just before 1, just it needs a little bit to be equal to 1. It is smaller, still smaller than 1. So as you see, this is what we mean by we are approaching 1 from the left. This is what we mean by, for example, 0.9 is as x tends to 1 minus means as x goes equal to 1. 0.9 or whatever, something just less than 1. So as we do so, as we approach 1 from the left side, what happens to the curve? It's going downwards towards minus infinity, and that's to write that limit as x tends to 1 minus of f of x, the function, is equal to minus infinity. So remember, and its limit as x tends to 1 plus from the right side was plus infinity. Regardless of the sign, what we care about is just the infinity. So because both limits are infinities, whether 1 minus or 1 plus, whether going to 1 minus or 1 plus, we care about the infinity regardless of the sign. Then we say that x equals this one, this value, regardless of 1 plus or 1 minus, just x equals 1 is a vertical asymptote. That's about the vertical asymptote and about the limits at infinity and the horizontal asymptote as well. Now let's talk about another curve. This is a curve that appears to be continuous somewhere and discontinuous somewhere. Okay, so here is this curve. Notice that. Okay, again, let's talk about the limit at plus infinity, at minus infinity, and so on. Okay, so the limit as x goes to minus infinity, let's take x to minus infinity. So as if we are moving that way. As x goes to minus infinity, look what happens to the curve. This is the curve where the curve is going at minus infinity. So limit as x tends to minus infinity of f of x is equal to this value. It's limited by this value, which is 3. And thus we say that y equals 3 is a horizontal asymptote. Let's see its limit at plus infinity as well to see if it has one horizontal asymptote or two. As x goes to plus infinity means that way, notice, as x goes to plus infinity also the part of this curve is going to that value, which is 3. So again, the limit as x tends to plus infinity of f of x is also equal to 3, and thus there is one horizontal asymptote for this curve, which is y equals 3 is the horizontal asymptote for this curve. Now let's talk about the vertical asymptote of this curve. These are the green lines that are the vertical asymptotes for this curve. Notice that as x tends, notice, as x tends to minus 2, I guess the points that we need to study the limit at are the roots usually of the denominator. So this curve is about a curve that has a denominator, and the roots of the denominator are minus 2 and 2. That's why we have vertical asymptotes at them. So it's clear that I have to see the limit as x goes to -2 minus. So let's move the slider. As x goes to -2 minus means this is the point approaching -2 from the left, not the red point. So it's -2.1. It's just still less than -2. So it is going to -2 from the left, means it's less than -2. And here if we move it, it is still less than -2, and here it is equal to 2, to -2, sorry. Okay, so as we say, x tends to -2 minus, then we are still a little bit less than -2. Now, what happens to the curve in this region? As x tends to -2 minus, the curve is going upwards toward plus infinity. So we write that limit as x tends to -2 minus, from the left we mean, of f of x is equal to plus infinity. Let's study the limit at -2 plus. So that way, as x tends to -2 plus, I mean that way. So x tends to -2 plus from the right. It's going to -2 from the right, and again we use the sliders, so notice it is -1.75, -1.8, -1, -1.9 until it reaches -2. So that's what we mean by x tends to -2 plus, approaching -2 from the right. Let's see what's happening to the curve. The curve is going downwards. That's what to write now. Limit as x tends to -2 plus of f of x is equal to minus infinity. Again, regardless of the sign. So the limit as x tends to -2 in general is equal to infinity. The limit is infinity. Then we directly say that x equals -2 is a vertical asymptote, and again, regardless of the sign, just we care about infinity. That's about the first vertical asymptote, which is at -2. Similarly for the second asymptote, so we are going to talk about it in brief. Similarly for the other vertical asymptote, which is at 2. Again, let's move the slider. It's approaching 2 from the left side, so it's like 1.8, 1.2. So as x tends to 2 minus, I mean as x approaches 2 from the left side, what's happening to the curve? The curve again is going downwards towards minus infinity. Then we say that limit of f of x as x approaches 2 minus is equal to minus infinity, because the curve is going downwards. Now let's talk about the limit at 2 plus. So as x approaches 2 from that way, from the right, then limit as x approaches 2 plus of f of x is, so again we move the slider. Here is 2 plus, notice it is 2.1, 2.05 until it reaches 2. So that's what we mean by 2 plus. Let's see in that region what's happening to the curve. The curve, as we approach 2 from the right, the curve is going upwards. So that's to say that the limit as x tends to 2 plus of f of x is plus infinity. So again, regardless of the signs, whether minus infinity or plus infinity, what we care about is that the limit as x approaches 2, whether from left or from right, is going to infinity, whether plus or minus, and thus we say that x equals 2 is a vertical asymptote. So this has one horizontal asymptote, which is y equals 3, and 2. So we have, let's write it. So there are two vertical asymptotes. One of them is x equals minus 2 and the other is x equals 2, and one horizontal asymptote which is y equals 3. Now let's talk about the discontinuity of the function at 3. Okay, so after we talked about the asymptotes, the limits at infinity, the limits at the roots of the denominator, and the horizontal and the vertical asymptote, we are now going to talk about the discontinuity of this curve or this function at 3. Let's look here. Let's talk about, or let's concern the limit as x tends to 3 minus. So let's talk about the limit as x tends to 3 minus, i.e. from the left side. So again, let's move the slider. So we are approaching 3, look, we are approaching 3 from the left. So as if there is here like a separating line. Okay, these are two parts of the function, and as we approach 3 from the left, what is the limit? Look at the limit. So as we approach 3 from the left, the limit is equal to 6. So the limit here is equal to 6. Let's see what about as x approaches 3 from the right. So as x goes to 3 plus means as x approaches 3, here is the moving slider. So as we approach 3 from the right, so it's like, look, it's like 3.15, 3.05, whatever. That's what we mean by approaching 3 from the right, sorry, approaching 3 plus. Look at the limit here. The limit is in that we concern that part. Okay, so the limit here is what? It is something between 3 and 4. Let's say, for example, let's say 3.7, for example, or 3.8. What we care about is that it is different from 6. The limit as we approach 3 from the left, as x tends to 3 minus, is 6, while the limit as x tends to 3 plus is something between 3 and 4 and not 6. So the limits here are different. Okay, then definitely we say that this curve is discontinuous. That's proving it discontinuous. And f of 3, let's delete that one. F of 3 is exactly when we have it at 3. So f of 3 is 5. So neither the limit as x tends to 3 minus is equal to the limit as x tends to 3 plus and is equal to the f of 3 itself. The 3 are different because f of 3 is equal to 5, and thus that proves why this function is not continuous.